submerged as equal to 0.258 newtons. Okay, so sorry, I made a mistake on the volume. Instead of writing to the power minus 5, I wrote to the power minus 4, which kind of like tempered with the rest of the answers, but I've made corrections, and this is the actual way to go. So if we reach this part, that means we've completely answered question 7, and we can now move on to question 8. So let's look at what question 8 is saying. Question 8 is saying, suppose a 60 kg woman floats in fresh water with 97% of her volume submerged when her lungs are full of air. What is her average density? Suppose a 60.0 kg woman floats in fresh water with 97.0% of her volume submerged when her lungs are full of air. What is her average density? Okay, so let's do this. This is question 8, and they've given us data to say we have mass of the woman to be 60 kilograms. They've given us a percentage of the body that is floating. Say 97% is submerged. So she's floating whilst 97% of her body is submerged. And we also have raw of water, even if they didn't give it, but we know to say the density of water is equal to 1000 kgs per cubic meter. Okay, so what are we going to notice now, or the approach that we are going to use to solve this question? We know to say, well, we're going to use floating at equilibrium. So we know to say when something is floating at equilibrium, what does that mean? That means the buoyant force, FB, is equal to the weight, like this. And we know to say buoyant force is equal to what? Buoyant force is equal to weight of displaced water. So it's one and the same. Buoyant force is equal to the weight of the displaced water. And what does that mean? That means the weight of the woman is going to be equal to what? So weight of woman will be equal to the weight of displaced water. As simple as that. So the weight of displaced water is going to be equal to the weight of the woman. Now let's write this equation in its mathematical form, or in its physics form. So this is going to be equal to what? We have the mass times gravity, which is the weight of the woman, being equal to the weight of the displaced water. So the displaced water will be equal to what? Will be equal to the rho of the water, which is the density of the water, multiplied by the volume, multiplied by what? Multiplied by the gravity, like that. So V here is the volume of, or the volume of the woman's body that is submerged. Since that is the water that is getting displaced, it's the volume of the woman that is actually submerging. So the submerging volume is equal to the volume of the water that is actually getting displaced. So this is the V here. I'll represent it as Vs to just show that it's the volume of water that is getting displaced. And they've given us a percentage of her body that is actually submerged. To say she's floating, but 97% of her body is submerged. So we know to say of a total volume of the woman, 70 or 97% is the volume that is displacing the water. So what are we going to say? We're going to say this number multiplied by the volume of the woman divided by 100%, since we're using percentages here. So that means the volume is 0.97 V. This is the volume of the woman that is submerged, where V is the total volume of the body. As simple as that. So from there now, what are we going to do? We can see to say gravity is applying on both sides of our equation, so we can cancel out that gravity and can also cancel out that gravity. So we're remaining with mass on the other side, which is mass over the woman. So M here will be equal to rho of the water, which is density of the water, multiplied by what? Multiplied by the volume of the woman that is submerged, also known as the volume of the water that is displaced. So we're going to multiply this by 0.97 V, like that. Okay, as simple as that. So we are looking for V here. We already know the density of water. We already know the mass of the woman, and 0.97 has already been calculated as a constant there. So what are we going to do? We're going to say V will be equal to mass of the woman divided by 0.97 multiplied by rho of the water, which is density of the water. And from here, you can also calculate the woman's average density. We'll just rub here. From here, you can also calculate the woman's average density. To say P of the woman, average density of the woman will be equal to the volume, or rather 0.97 multiplied by the volume of the water. I mean the density of the water, which is 1000 kgs per cubic centimeter. And this is going to give you average density of the woman to be equal to what? To be equal to 970 kgs per cubic meter. 970 kgs per cubic meter. This is the actual density of the woman. This is the actual density of the woman. Where are we getting the actual density of the woman? It's because if we have this as the volume of the woman or displaced water, we're going to say density, which is rho of the woman, is equal to what? It's equal to mass over volume. And mass over volume, we're just getting that same mass divided by this equation that we're having here, and that is going to give us the average density of the woman. So I didn't show the whole process here because it is as simple as that. Volume is equal to mass over volume, and we're going to get that percentage multiplied by the actual density of the water to find what we are looking for, which is the average density of the woman. I hope that's clear. And that ends up, or that finalizes question 8. Let's move on to the next question, which is question 9. So question 9 is saying a nozzle with diameter of 0.500 centimeters is attached to a garden hose with a radius of 0.900 centimeters. The flow rate through hose and nozzle is 0.500 liters per second. Calculate the speed of water through A, the hose, B, the nozzle. The nozzle with a diameter of 0.500 centimeters is attached to a garden hose with a radius of 0.900 centimeters. The flow rate through the hose and nozzle is 0.500 liters per second. Calculate the speed of water through 1 or A, the hose, and B, the nozzle. Okay, so question 9. This is question 9. And they've given us a diameter of the nozzle. Okay, this is 0.500 centimeters. Then we have radius of the hose. Radius of the hose to be equal to 0.9 centimeters, like this. Then they've also given us the flow rate. Say this is equal to 0.5 liters per second. And we know to say the SI unit for volume is the cubic meter, whilst the SI unit for time is the second. So we're supposed to convert this into cubic meters per second. And this is actually going to give us 5.0 times 10 to the power minus 4 cubic meters per second. So this is the flow rate in its SI unit. Okay, so now that we've converted our flow rate, what are we supposed to do? We're supposed to find the cross-sectional area of both the nozzle and the hose, provided the radius and the diameter that we've been given in the question. So on the nozzle, or we'll start with the hose, the cross-sectional area. I want to find area of the hose. Since this is a circular hose, area is going to be equal to pi r squared, of which this will be equal to what? This will be equal to pi multiplied by, they've given us the radius here, which is in centimeters, and we're going to convert it into meters by dividing it with 100. So this is going to give us 0.009, like this. I'm going to put 0.009, then squared there, which is going to give me cross-sectional area of the holes to be equal to 2.55 times 10 to the power minus 4 cubic, or square meters rather. This is the cross-sectional area of the holes. Then we can calculate the cross-sectional area of the nozzle here. And since the nozzle is also circular, we're going to use the same formula, pi r squared, which this will be equal to pi multiplied by the radius. So they've given us the diameter here. We're going to divide this guy by 2 to find the diameter into, or to find the radius. So this will be equal to 0.25 centimeters as the radius, and we're going to divide this by 100 to convert this guy into meters, which this is going to give me 0.0025 meters, and this is the guy that I'm putting in my brackets, 0.0025 meters squared, and this is going to give me the area of the nozzle, the cross-sectional area of the nozzle, to be equal to 1.96 times 10 to the power minus 5 square meters. So we have the cross-sectional area of both the holes and the nozzle. So what are we going to do? We're now going to use these areas to find the speed of the water in both the holes and the nozzle. And how we're going to do this? We're going to use the principle of continuity. So the principle of continuity is to say Q is equal to area multiplied by what? Multiplied by velocity. So we're going to say velocity in the holes will be equal to Q divided by area of the holes, whilst velocity in the nozzle will be equal to what? Will be equal to Q over area of the nozzle, like this. So let's use this formula. Find the velocities. So we're going to say velocity in the holes will be equal to 5.00 times 10 power -4 divided by 2.55 times 10 to the power minus 4, like this. And this is going to give us the velocity in the holes of 1.96 meters per second. Whilst the velocity in the nozzle will be equal to Q again, is 5.00 times 10 to the power minus 4 divided by 1.96 times 10 to the power minus 5, like this. And this is going to be equal to 25.5 meters per second. So we found the velocities, flow in both the nozzle and the hose using the principle of continuity after finding the cross-sectional area. The Q that we've used is just the flow rate. Q here is equal to flow rate over the area of both the hose and the nozzle respectively. So which means the velocity in the nozzle will be equal to 25.5 meters per second, whilst velocity in the hose will be equal to 1.96 meters per second. And that is all on question 9. That is all on question 9. Let's look at the last question, which is question 10. Question 10 is saying a large storage tank open at the top and filled with water develops a small hole in its side at a point 16.0 meters below the water level. If the rate of flow from the leak is equal to 2.50 times 10 to the power minus 2 cubic meters per minute, determine A, the speed at which the water leaves the hole, 2, or B, the diameter of the hole. Okay. So this is the last question, question 10. And in this question, they've given us to say the hole is located at the depth of what? Of 16 meters from or below the water surface. Then they've given us Q, which is the rate of flow. Say this is equal to 2.5 times 10 to the power minus 3 cubic meters per minute, like this. So the first things first, we're supposed to convert the flow rate into its SI unit, which by so doing, what are we going to do? We're going to convert these minutes so that we have a flow rate in cubic meters per second. So what are we going to do? This is the same as we have over 1 minute. So I'm going to say times 1 minute over 60 seconds. So the minute and the minute disappears, which means I'm dividing this number by 60 seconds. That means I'm going to get a flow rate Okay, so that means my actual Q. Oh, why did I rub everything anyway? So my actual Q after converting it will be equal to 4.17 times 10 to the power minus 5 cubic meters per second, like that. Then we said our H was equal to 16 meters below the water surface. So in question A, they are saying we should calculate the speed at which the water is leaving the hole. And we also didn't, I also didn't finish looking at this part, but we are simply going to use the Dirichlet's theorem to say velocity will be equal to what? Will be equal to 2gh, like this. Of which this is going to be equal to the root of 2 multiplied by 9.81 multiplied by the height below the water surface, which is 16. That means our velocity will be equal to the root of 313.92, which will be equal to the final answer 17.7 meters per second. So this is the velocity at which the water is going to be leaving the tank. And part 2 is saying we should calculate the diameter of the hose. Part 2 is saying we should calculate the diameter of the hose. And on this one, we're also going to use the principle of continuity, of which we understood to say on the principle of continuity, Q is equal to area multiplied by the velocity of flow. So the area, since we're trying to find the diameter, we're going to say the area is equal to what? The area is equal to Q over the velocity. Well, from calculating the velocity there, so we can just plug it in. We already have the flow rate, the one that we converted. So we're going to have this is equal to 4.17 times 10 to the power minus 5 divided by 17.7. And this is going to give us the area of the hole, which is equal to 2.36 times 10 to the power minus 6 square meters. So this is the area of the hose. Now they've taught us that we should calculate the diameter of the hose and not the area of the hose. So we know to say, in order for us to calculate area of the circle, we're going to say area is equal to pi r squared, like this. So let's find the radius. So let's make h the subject of the formula. So I'll divide both sides by pi, or making r the subject of the formula rather. I'll divide both sides by r squared, or by pi rather. Cancel out on the other side. I'm having r squared is equal to cross-sectional area divided by pi. Introduce the root sign on both sides to cancel out the square. So radius will be equal to area over pi, like this. So this is how we're going to get our radius. So our radius will be equal to the root of the area. We're calculating to say this is 2.36 times 10 to the power minus 6 divided by pi. I'm going to dash this the way it is in my calculator. I'm getting inside the root 7.51 times 10 to the power minus 7, which if I continue punching this, I'm getting radius, which is equal to 8.67 times 10 to the power minus 4 meters, like this, as the radius of the hole. And to calculate the diameter, we're just going to multiply this guy by 2. Since it's the radius, I'm just going to multiply it by 2 to get the diameter. Hence, diameter will be equal to what? Diameter will be equal to 1.73 times 10 to the power minus 3 meters. So that is the final answer on question 10. And when we reach this question, that means we're done with the whole tutorial sheet. Because the last question was to find the diameter of the hole, and we found to say it's 1.73 times 10 to the power negative 3 meters of diameter, of which this guy can be directly converted into millimeters by multiplying it by. Okay, so this is the same as if we multiply it by 1000, it is going to give us 1.73 millimeters as the answer that has been provided in the tutorial sheet. So that is the final answer. Thanks for remaining with us, and I'll see you in the next topic. Thank you very much. This marks the end of Unit 1, where we're talking about mechanical properties of matter and fluid mechanics.